Okay, I'm going to cover two topics that I didn't have time to discuss this morning. I hinted at them. This is French connection and image analysis and the role that Tom Stockton played in my work. So the French connection, this is an answer to the question, why did you come to Utah? How come did you come to Utah? And how come so many French people came to Utah? Well, it all began in Berkeley with Jean-Yves Leclerc, who was a student of Dave Evans, and impressed Dave so much that Dave decided that whoever Jean-Yves Leclerc would send to him, he would take, no question asked, until he sent him a turkey. So this was the rule of the game. If you came to Dave with a Jean-Yves Leclerc recommendation, he would take you. And this is what happened. I wanted to pursue my education in the States, in the West Coast, so I applied to Stanford, UCLA, Berkeley, and Utah. Okay? And I had a recommendation for Utah. I was accepted. I didn't have any recommendation at the other places. I was not accepted. And I think this is the best thing that happened to me, that I had no choice to make. I went to Utah. So I arrived in Utah in the fall of '68 with my wife Sylvie. And I was thrown in the pool of the department with all of the good things that have already been discussed. As an example, I mean, I was a newbie. I didn't have any notion of the culture and research culture in the US. And Dave told me, here is some travel money, go to San Francisco, there is a fall joint computer conference happening. I'm sure you'll learn a lot of things. And so I happened to have been at the mother of all demos and the fall joint computer conference. And that I heard for the first time the discussion about the matrix multiplier and the clipping divider and so on. I didn't meet anyone. I was shy, but I strolled around and came back, with lights in my eyes. So when I arrived in Utah, there were already two other Frenchmen that had been there for a few months, Robert Mal and Denis Serror. And we started to work with no specific plan according to the Utah department rule, do what you think is best. Now, of course, I had said this morning, I had decided to do graphics. I had entered through the back door into Ivan's class and so on. The next year, one of my good friends, I had been in school with Patrick Baudelaire, wanted to come to the US. So I told him, Patrick, Utah is a place to come. So Patrick came, and another friend, Daniel Debrosse, came. And this started the whole process of Frenchmen coming to Utah. The next one was Buitong Fong. He was a researcher at INRIA and wanted to do graphics. And he was planning to be there in '71 and overlap with me. Unfortunately, he had caught cancer and was delayed and came only after me. So I didn't get a chance to meet and work with Fong, but certainly his memory is very much present in the discussion and presentation you have. He is the one responsible for the name Gouraud shading. I had called it smooth shading. That felt good enough. But he had to distinguish his shading from mine. And so he christened the name Gouraud shading. And then after two other persons came, André Marchal, who worked on some language issues, and Olivier Faugeras. And I think Olivier is definitely one of the most brilliant researchers in the domain of vision and today of biocomputing and bioengineering. So this is the story of the French connection. I don't think that it lasted beyond that, beyond Olivier. I'm not aware of Frenchmen that came after, but certainly all of us were very happy to be in Utah. The other topic I want to cover is the relationship between image synthesis and image analysis. The topic of multidisciplinary activities has already been hinted at, and I definitely believe that this is indeed a very powerful concept. I was working on graphics with Ivan, and the domain there was vector display, matrix multiplier, clipping divider, and the goal that Ivan had assigned me was to use the Kunstpatch capability of the matrix multiplier to produce an interactive system where you can stretch a volume and shape it the way you wanted it to be shaped. And he used the term, build me a telephone set, a telephone handset, as an example. Okay? It was using the vector mode of the matrix multiplier and computing finite difference equation and so on. All of that was fine. A photograph of the Green Monster. It's amazing that this machine survived a move from Harvard to Utah and was still working. I got it to produce Kunstpatches. And in fact, on the video that you've seen earlier, the video presentation, at one point in time, there is a picture of Dave Evans leaning on the shoulder of a student with a Kunstpatch on the screen. Well, the student is me. Okay, and it is one of the Kunstpatch produced by the matrix multiplier. But you can see only the back of my head, so it's no surprise that nobody recognized me. At the same time, there was another class which I liked very much, which was Tom Stockham's class. Now, one of the things that we Frenchmen came as a reputation was that we were strong on math. And indeed, for the preceding 4 years, we had been dealing with matrix geometry, analytical geometry, matrix multiplication, integral, Fourier transform, and all of that. And we were very familiar with those domains. And we had this reputation at least. I don't know how good we were at it. So the course on signal processing that Tom was teaching was very appealing and very exciting. And I took great pleasure in listening to these classes and also in helping Tom in some of the experiments he was putting together. In particular, I was very active with him in setting together the high precision display equipment, which you see on the bottom left of the screen. Now, this was an oscilloscope with a flat face, with a neck which was about 1 meter long, okay, for very high precision. Tom had built DDA converters of 12, 14 bits, I don't remember, very accurate. And we mounted that on a large I-beam that we got from some engineering department, that weighed a ton. And we put on top of it an XY machinery to control the position of the camera out of some machine shop at the university. And there was a cover that we could put on top of it to avoid any light coming in. Here you see it without the cover. And the picture on the right is a test picture that was shown. Now think about it in terms of open shutter. Okay, it took about 1 minute to 2 minutes to paint the whole picture on the screen out of the memory of the PDP-10. And so we had typically to see the result, we had to put a camera in front of the screen, leave it open for 2 minutes and process the film, or alternatively use a Polaroid camera and see the result, okay? So, and here you see 2 pictures resulting from the work of Tom back east, where he was doing research on what happens in the retina when some picture comes in before reaching the brain. And he wanted to understand this process, and he came with the notion that, in fact, what the retina does is to increase contrast in an image, okay? So that we pick out the details much more efficiently than if there was no such process. And this notion I really understood and took in for the future of my work. I was doing the display of Kunst patches with, in a wireframe, and it was very clear to me that one Kunst patch is enough. If you put 2 or 3 Kunst patches on the screen, it's going to clutter the screen and you won't understand at all the shape that you're dealing with, especially if you go away from the sphere and torus and donut and whatever, which are well-known surfaces that our brain understands. If you take a random surface, you will not understand what it looks like just by looking at it. And so I wanted to go and bridge the gap with what my colleagues next door were doing, namely removing hidden line and shading the images in a solid fashion. Now, to do that, I was dealing with smooth curves and surfaces, so I had a problem, and I didn't, the solution of increasing the number of facets to represent the surface was not an appealing one, because it was, hard on the hardware, n square problem or n log n, so it was expensive. But on top of that, the retina was fighting against me. The slightest difference between 2 facets would be picked up by the retina, and the contrast increased. So I said, solution, remove the difference between 2 facets. Organize the shading of the facets so that there is no difference between 2 adjacent polygons. Now the question becomes, how do I test the idea? Okay, and I had, I was dealing with interactive Kunst patches. I was not dealing with hidden line removal and shading. And that's where the notion of sharing, of community at the department became in full strength, because next to my office was Gary Watkins. And what Gary was doing is building a program that was simulating his future machine, which was rendering shaded images of faceted objects, okay? And I said to Gary, can I borrow your program and play a little bit with it and change it in the fashion that I would like to test the idea? And he said, yes, go ahead. So I took Gary's Fortran program. I didn't look into it beyond searching for places where he was manipulating X, Y, and Z. And I added a force coordinate, which I call I, for intensity. Okay, so I scanned the program. Whenever it was manipulating segment of 3, 5, and 7, I would add, another set of data, which was the intensity. So I slightly modified the program, maybe 20, maybe 30 lines of Fortran. I didn't look at the overall structure of the program because I trusted Gary to have done a good job. And I ran it, and it worked. It produced a picture of a sphere. Now, the data I had chosen was a sphere because it was, I had nothing to display. And producing a set of facets for a sphere was an easy mathematical stuff, so I did it. And I showed that sphere to Ivan, and Ivan said, it's nice, but it's not extraordinary. And what happened then is that a few weeks later, Ivan came back and says, can we play the trick on any object? And I said, yes, provided you give me the data. And he said, right on. He sent someone at ENS to measure a T-37 airplane plastic model. Okay, I didn't do it. Someone at ENS, I don't know whom, did it, measured the data, gave me the set of polygons, and I produced this picture. That picture was intended to be part of an ENS proposal to the Air Force. And when Ivan saw that trick applied to a real object, he said, that's it. You have your degree. Write it up. Okay? And I was stuck with the notion of, transforming two lines of mathematics of linear equation into a multi-page dissertation, and that was the next job. Okay. So it took me a while, and Ivan helped me a lot, formulate and organize my ideas and so on. Okay, and then during the writing of the dissertation, I was, displaying car bodies and airplanes and the donuts and Taurus, nothing very amusing. And then one dinner, I said, I know what I want to do, something which is fleshy, which is non-geometric, mathematical. So I said, Sylvie, can I paint on your face a set of lines, with eyeliner? And she said, yes, why not? She is very kind with me, okay? And I took two pictures, you have only one of them here, front and side, gave them to Mike Milocek. The day after, I had large prints of those pictures that I measured with a ruler, and I produced the 3D model that you're familiar with now. And the picture in the bottom are a second try at measuring Sylvie's face with better polygon mesh and a smile. We were starting to go toward animation, but I never measured and used that data set. And on the left, you can see Ivan helping making this measure. Now, before leaving that subject, I want to pick up on one of the slides that Martin just showed. What I did, in fact, is nothing very fancy, because what I did was to say we can paint an object according to our wish, not according to the geometry of the object. Okay? What I did was to fake paint on the object so that you don't see the boundaries anymore. And in fact, painters have been doing that for ages. On a flat sheet of canvas, they paint something that looks 3D, okay? So this notion is there. And the funniest comprehension of this phenomenon came a few months ago when I encountered an artist that was using my technique quite extensively to build avatars, okay? And he said, Henri, I was very disappointed because I had those nicely smooth shaded avatars, and then when I wanted to print them on my 3D printers, they came out faceted. And so I had to explain to him, but that's normal, the geometry is faceted. It's only the painting on the screen that is smooth. If you 3D print, you're only 3D printing the geometry. Okay. So, I mean, just telling you all of this story brings me back to my memory, all those good times. So, but I want to terminate with a picture which I could not resist showing you of the fun we had while being at Utah. This is a costume party at Bob Taylor's place in '69, where you will recognize many of the people, probably quite a lot of them are present in this room. In the middle, you have Dave Evans and his wife, Joy, and you can see on the top left, you have Sylvie, which is on a dress made out of punch cards, stitched together. You have Tony Hearn. I'm hiding behind the box, okay? You have, on the next picture, you have Ivan and Chuck Seitz. On the picture on the far left, you have Patrick Baudelaire and Isabelle. On the bottom, you have Bob Taylor, Tony Hearn again, and Bob Barton on the left. Okay, so all of those, I would like to put a name on all of those people, and some of you may help me do that. But this is how lively the group at Utah was, a big family where we were greeted at Dave's home, Ivan's home, Tom's home, and sharing good memories. Thank you.